Okay. Alright, the number of tight scores is 5. Okay, the sum of the positive ranks for the different score is 789. Okay. What is the expected value of the Wilcoxon sum of positive rank statistic R plus, given that the null hypothesis is true? It's equal to the number of scores that are left times the number of scores that are left plus 1 divided by 4. So let's see, we had 51 individuals, and because 5 of those are gone because they were tied scores, we have now 46 left. Okay, so 46 times 47 divided by 4, that's what I'm looking for. That's the expected value, so I got 540.5. Alright, what is the value of the sum of positive ranks in this experiment? Okay. Let's see what the value is of the sum of positive ranks. I believe we were told this. We were told this in an earlier step. It's 789. Okay, so I'm just going to put that in there. Okay, which research hypothesis is appropriate? So here you have to think a little bit, because first let's see what the question was asking. Is there a directional test or a non-directional test? Wanted to know if coffee drinkers would perform better or worse. So this is easy. You don't have to think about, because it's not a directional test, you don't have to think about, okay, which column did I subtract from which, and then am I expecting the different scores to be more positive more than negative if the research is correct, and so on. So you don't have to think about that. You just know that because it's a two-tailed test, the sum of positive ranks should just not be equal to the expected value. So the answer is C. Okay, compute and enter the standard deviation of the sum of positive ranks given that the null hypothesis is true. Because we're using the z approximation to the sum of positive ranks in this case, because the central limit theorem applies, what you have to do is go and look up if you don't have it, look it up. Okay, this is lecture 11C that I have, or at least this is from last year, but it probably is still the same. So the standard deviation is going to be equal to this. Okay, so I'm going to compute that. So the number of pairs I had was 46 multiplied by 47 multiplied by 2 times 46 plus 1. So that's 93. Okay. Okay, so 46 times 47 times 93. Divide that by 24. Take the square root. Okay. Round off to 6 decimal places. Okay, so 91.53. No. Okay, that's 6 decimal places. Or actually, this rounds up to something else. Sorry. Alright, so this should be correct. Okay, enter the value of the test statistic. Okay, the test statistic is simply going to be the sum of, the test statistic is going to be the z-score that you're computing using this equation. Okay, sum of positive ranks minus the expected value divided by the value you just computed. So the sum of positive ranks, again, was given at 789 minus the expected value, which is 540.5, divided by the number I just computed, which is 91.53005. Okay, 2 decimal places, it's 2.71. Okay. All right. Enter the test statistic value corresponding to the lower boundary of the acceptance region. All right. This is a two-tailed test, so I have to look up what alpha I was told to use. Let's see. It says 0.05. Okay. So for a two-tailed test, the lower boundary, the area has to equal 0.025. It's probably going to be probably going to be 1 minus 96 or something close to it. Yep. And for the upper boundary, because it's perfectly symmetrical, it's going to be the positive value. Okay, so this is the acceptance region. Do we accept or reject? We reject because the value we got was 2.71. It falls outside the acceptance region.